Assalamualaikum, my name is Muhammad Hazir Hakimi and this is Power Amplifier Lab 7 Part 1. So this is the circuit given and we need to construct in a Proteus. So this is the circuit that has been constructed. Okay. For resistor, 2 capacitor, 3 capacitor, NPN, 2 NPN, and battery also sign voltage in, V in. Okay, so start simulation. Okay, we get the value of VBE1 and VBE2. Okay, the value of VBE1 62.7 and VBE2 15.8. Okay, so this value. Okay, then we have to set the input 1 kilohertz, 70V peak to peak, V in, record the output waveform. So we already put the value peak to peak 7 and frequency 1 kilohertz. Okay, and this is the result for the waveform. You can see. Okay, and this is after we change it to bitmap. Okay, so observe waveform and note the amplitude and period of the input output. So input 3.5, output 2.8. As we can see 3.5. Okay, output is red and input is green one, so 3.5 and 2.8. Okay, and we can see the period is 437.247 m. Okay, same. So based on figure 2.3, can you describe the difference between input and output? So we can see that the red one is output while the green one is input. For the output, we can see unstable condition on the waveform due to the circuit orientation by effect of R1, R2 and R3. Okay, so as for result conclusion, we can see the waveform of input and output are called as linear amplifier because the output signal amplitude and phase are linearly related to the input signal amplitude and phase. Okay, as we seen, same. Okay, so calculate the RMS output power PO of the amplifier. So the formula of power output is V square equal to RL. So we know that V square is 7 RMS and RL is equal to 1k ohm. So 7 square and 1k ohm equal to 49 watt. Okay, and that's all for me for part 1. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurami Robi Anwar. So I will do for this lab part 2, which is class AB power amplifier. So we need to change the resistance with diode. So this is the circuit for part 2. First we need to display input and output waveform. So we need to put the peak to peak value 7 and frequency 1 kilohertz. So this is the waveform for 7 peak to peak, which is V out is 3.38 and V in is 3.5. So next we need to change the input signal to give maximum undistorted waveform. So if we change to 9 peak to peak, the waveform still have the distortion. So we need to change it to 8 peak to peak. And the input and output doesn't have distortion, which is this is the maximum for undistortion waveform. So next we need to measure the RMS voltage. So for the RMS voltage, we put the AC volt at the RL resistance, which is 1K. So we simulate it and we got 2.75 for VRMS. So for measure the VBE1 and VBE2, we need to use DC voltmeter and put this part, and we can run for the volt is 0.61. Both are same, and if we change to millivolt, we got for the VBE1 605 millivolt and VBE2 309 millivolt. Next is to describe the difference between the input and output waveform. So the difference is value for Vout and Vin, which is Vout is 3.38 and Vin 3.48, which is a little bit different. So the output becomes smooth and no more distortion because the effect of the diode. Next, we need to calculate the VORMS, ICC, PDC, and percent of N. So for VORMS, we use formula VP divided by the power square root 2. We got 2.72. For the ICC, we use formula VCEQ divided by RL, which is we got the value 2.72 milliampere. For PDC, we get 0.0 watt, and lastly for percent N, and we got 56.56%. So for the explain how to change the input signal to give the maximum undistorted output waveform. So we change the value P to P until we get the waveform. So we got the undistorted waveform with 8. The P to P value is 8. So for the conclusion, we able to demonstrate the design and operation of a Class B push-pull emitter follower power amplifier. We use the Proteus software to build that circuit, and the result that we got is the condition waveform for the Class B is distorted because the effect of resistance. And next, we also able to demonstrate the design and operation of a Class AB, that we can see the graph for this operation smooth and no distortion happen, and it is because effect from the diode. That's all. Thank you.